Next up, I'm going to be showing you how to solve the ALEKS problem. Draw a skeletal structure for the molecular formulas listed below and do not include lone pairs. So with skeletal structures, they are kind of more simpler to look at versus having to draw a Lewis dot as we did in the last example. But the skeletal structures follow certain rules, such as hydrogens are not shown on the skeletal structure. Other elements are. So by that, when I think of, say, the first one, which is C5 and H12, you have to picture it this way. When you have just a straight line or a carbon just attached to one of the carbon, this outside carbon here, you have to imagine that it has three hydrogens around it to satisfy the octet rule, such as here, right here. So it's attached to a carbon, and then it has a hydrogen here, here, and here. But that won't be shown on the overall skeletal structure. Now for CH2, say a carbon is going to be attached to two different elements, rather carbon or anything else, you're going to have to picture that it has two hydrogens attached to satisfy the octet rule. Now, another example is, say we have a carbon right here and it's attached to three different elements, then you just picture to satisfy the octet rule, it's only going to be attached to one hydrogen. And then if a carbon is attached to four different elements or four other carbons or whatnot, then it's not going to have any hydrogens attached to it. So the way that I like to solve this problem is by first drawing out all my carbons. So in this first problem, they're asking us to solve for carbon 5H12. So to draw all the carbons out, I go 1, 2, 3, 4, 5. So let's count the carbons. 1, 2, 3, 4, 5. Next out, I count my hydrogens based on the rules that I just mentioned above. Because this carbon is attached to only one other carbon, you in your mind you're going to have to think that it's going to be 3, 1, 2, 3. So 3 right here, and since this is the same thing right here, you could just in your mind think of it as 3 that are right here. So that's 6 of the 12 that's needed. And then I have two hydrogens here based on the rule that we put out here, two hydrogens here, two hydrogens here. And so this is what we're looking for C5H12. Now, sometimes the hydrogen numbers might differ. So in that case, when you draw your structure, sometimes think of adding in factors such as double bonds or whatnot so that you can reach that hydrogen number. Now, next up, we have C2, H4, and Br2. So you got your two carbons that are right here, 1 and 2. And next up, to each of those carbons, you have a Br attached to each of them. Because of that, that means both your carbons right here only have enough room for two hydrogens. So according to the rule here and how it's listed, so it's 2 right here, 2 right here, which give us our overall number of 4. And so this will be our skeletal structure for C2, H4, and Br2. Again, I'll show it in combat speed or what ALEKS shows as right for it. But again, this just takes some practicing. It's introductory stuff to organic chemistry, and you'll see later that it makes things simpler, and it's only going to continue to build off of it. As always, if this helped you solve this problem, or if you even want to just clarify or message me to go more in details on it, feel free. But like, share, and subscribe to my channel. Thank you.